works. Okay, we're going to work on polynomial models in the real world, which means we're mostly going to be working with word problems.
Yay!
That's better. All right, and so here's where we're gonna start. There's not very much that you have to know differently than what we've done in the past. You just have to know a couple things about your calculator. So you can use polynomial functions to model real-world situations that we're going to talk about today. You can read all that stuff. We're going to be using our graphing calculators. We're going to be using the stat button where we type in things in columns. We're going to be using regressions. Sometimes the problem tells you it's a linear regression. Sometimes it tells you it's a quadratic or cubic. And then we're going to graph them and then answer questions based on that information. So we can graph things using a scatter plot. Remember, when you hit the y equals button, you have to go up and highlight plot 1. If you're looking at a scatter plot, that's going to be one thing that you need to do. The other thing on your calculator that you need to do is hit the second button and the 0, and then go down till you get to diagnostic on and make sure you turn that on. So I guess I can show you that as well, just to make sure that we've got everything set up and ready to go for what we're going to be doing today. So we'll turn on the calculator.
Do we just hit enter?
Yeah, you just hit enter and it says diagnostics turned on. Okay, so what I was talking about, hit second, hit 0. You go down until you get to diagnostic on, which is right.
I'll hear like hitting the enter button and that's already
Okay, diagnostic on, hit enter, and then hit enter again, and it should say it's on. Okay, it says done. All right, what that's going to do is that's going to show that R value that we looked at before to see how well the model fits with the points that we were given. And we'll look at that here in a little bit. Okay, so I can get rid of the calculator for a second. So if you'll remember, when we were given tables, one way that we solved things, we hit the stat button, went to edit, typed in L1 would be all of our X's, L2 would be all of our Y's. We're going to do some of that again today as well. So a lot of this is just going to be review. All right. One of the concepts, the only one in this section that we're going to really talk about, is this n plus 1 point principle. And here it's pretty easy. It says for any set of n plus 1 points in the coordinate plane that pass the vertical line test. Remember, if it passes, you guys remember the vertical line test?
Yeah.
If you can draw a vertical line and it passes, then it's a function. Okay? There is a unique polynomial of degree at most n that fits the points perfectly. This is complicated talk for going backwards from what we talked about the other day. Remember we said we knew how to determine how many terms there were by taking the degree and doing what? If it's cubic function, how many terms should there be? There should be 4. There's the x cubed, the x squared, the x, and then we add 1 for the constant. All this is going backwards, right? It tells you how many points you have, you subtract 1 of them, and then you get the degree. Okay? So that's what this is talking about here. It says this principle confirms that any 2 points determine a unique line. So if you have 2 points, you have a unique line that goes through the 2, which means there's one line that goes through 2 points. 3 points that are on a line determine a unique parabola. Okay? You guys know what a parabola is. 4 points that are not on a line or a parabola determine a unique cubic, and then so on and so forth. So if we went one more, then it would be quartic. You got it? All right. So that's what this is talking about. All right, here's an example of a problem of multiple ways that you can use your calculator to solve or to find a function. So here it says, what polynomial function has a graph that passes through the 4 points? If there's 4 points, what kind of function are we going to have? Cubic. Cubic, right? Remember we subtract 1. Okay, cubic. So by the n plus 1 point principle, there's a cubic polynomial, and that's how you write it, ax cubed plus bx squared plus cx plus d. That fits those points perfectly. I don't know if you remember this. You guys remember matrices?
Yeah.
Okay. So if you remember matrices, then what we did is we took the points and we plugged them in for x and set them equal to the y value. So this was a 0 cubed plus b 0 squared. That goes with that first point, 0 to 0, negative 3. When you plug in 0 for x, you should get negative 3 for y. We do the same thing for 1, -1, 2, 5, and -1, -7. And from that, we get this stuff over here, which we can make a matrix from. Okay, remember the augmented matrix we talked about? And so we type them all in. This is a matrix, a screen capture down here of the calculator. So you've got 0, 0, 0, 1, -3, 1, 1, 1, 1, -1, 8, 4, 2, 1, 5, and they're just the coefficients that are in front of A, B, and C, and D, right? And then the last column is just whatever's after the equal sign. So we have all of that stuff typed in, and then we do that reduced row echelon form on the calculator, and it gives us A is 1, B is -1, C is 2, and D is -3, and we take those and we plug them back in to this function right here. Okay, so we would get y equals x cubed, right? Everybody see that? Minus x squared plus 2x minus 3. And that would be our answer. It's right here. Okay? That's one way of doing it. But probably an easier way of doing it, since you already know that point principle, the n+1 point principle, and you already knew ahead of time it was going to be cubic, what you could have done is you could have taken those points and you could have typed 0, 1, 2, and -1 under L1 when you hit the stat button. You could type in -3, -1, 5, -7 under L2, and then go to second stat, go to calculate, and do the cubic regression like they did right here. And the cubic regression will give you 1, -1, 2, -3. Okay? And then you could have done it without typing in a lot of stuff. So if you wanted to see how that one worked, yeah, I could show it. Then you turn it on, hit the stat button, go to edit, and you're going to type in, what is it again? I missed it. 0. Does anybody remember the points, or do I need to do it? There we go. 0, 1, 2, and -1. And then you go over to the other side and you enter in -3, -1, 5, and -7. And then after you have that all entered in, you would hit the stat button again, go to calculate, and we already said we knew it was a cubic regression, so we hit that, and there it goes. X cubed minus x squared plus 2x minus 3. And it fits the points perfectly because our r squared value is 1. And it told us that it was going to fit them perfectly anyway in that n+1 point principle. Okay, so we're going to find a polynomial function whose graph passes through each set of points. Now if they give you 2 points, what kind of function are you going to have? It's going to be linear, right? You could do it by hand, but since this is a calculator section, we might as well just practice. So, get your calculator out, hit the stat button, edit. Remember, if you want to clear stuff, you highlight L1 and hit clear. Do not hit delete. If you hit delete, you're going to erase the entire, like L1 will disappear. Okay? So you go over here, you type in your x's, which are 4 and -3. And then over here you hit -1 and 13. Stats right here. Okay? Once you get them turned in, what kind of regression are we doing? Linear. So go to calculate, go to linear regression, hit enter again, and it tells you what your equation is going to be. -2x plus 7. Okay? Look at number 2. They give you 3 points. What kind of function are we going to have? Quadratic. Quadratic. Remember, you subtract one of the points. You got 2. It's quadratic. That's your degree. So you hit stat. It's right here. You hit edit. You can type over these numbers or you can clear them. 0, -2, and 2 are our x, and then our y is going to be -3, -7, and 9. And now when we go to stat, we're going to go to calculate. We're going to go to what? The quadratic regression. And they give us the answers. And those answers are going to be x squared plus 4x minus 3. And you can put y equals or f of x, whatever, if you wanted to. Okay? You probably should put at least y equals or f of x equals is probably even better for what we've been learning. All right, now, so this is find a polynomial function that best models each set of values. So we're going to do the same thing, except for you have to make sure you look and see which year it tells you to start with, because you're going to have to adjust your L1 column based on that row. So for this first problem, and then at the end, it wants us to estimate what the gold production is going to be for 2010, 2020, and 2025. So first we find the function, and then we can plug in x for those years to figure out what the production is going to be. So we get the calculator back out, move it over here to the side, hit stat, edit, and we can type over all of this stuff here. But now 1985, it tells us that's when we're going to start. So what should I type in for my first L1 value? 0. Or I can erase my calculator. We should be typing in 0, because that 1985 is the year that we start. It says years after 1985, so 1985 is our 0. So then 1990 would be 5, 1995 would be 10, and 2000 would be 15. Okay? Then we go over here and we just type these numbers in. 49.3, 70.2, 71.8, and 82.6. Oops, I hit the alpha button. There we go. Okay. Now we need to figure out the polynomial function. They give us 1, 2, 3, 4 points.
Cubic.
So it's going to be cubic, right? So we hit stat, calculate, and we go down to the cubic regression. We hit enter, enter, and they give us the function. And so we're going to want to write that down. So we've got point, or I should put f of x equals, or I should have done year, it doesn't matter, 0.038 x cubed minus 0.956 x squared plus 8.01 x. I need to move this calculator out of my way. Plus 49.3. Okay. Now, what we need to do is we need to kind of finish out the table. And write down what the gold production is going to be in millions for those years. And so what we'll do is we'll take this function, which we can turn my calculator back on, type in here. So 0.038 parenthesis, and we're doing 20, right? Is that right? No, it's not 20. It's not 20. It's 25. Does everybody see that? 25 is what we're going to be typing in for x, so that's 25 cubed minus 0.956, and I would use the parentheses because I'll show you why in a second, but just trust me on it. 25 squared plus 8.01 times 25 and plus 49.3. Is that right? Okay. And then we hit enter. And we get 245.8. I might have typed something in wrong.
That's what I got. I got the same thing. I definitely got something. What did you get, Chase?
Does that look good?
I got exactly what you got.
I guess it is cubic, so maybe it is going to start flying up, I guess, here at the end. So 245.8, is that what everybody got?
Yeah.
All right, well, let's trust ourselves then. 245.8. Okay. Now, you don't want to have to type in that whole entire thing every single time. If you hit second and you hit enter, it's going to put up the exact same thing we just typed. So we can go in, go back, and we can change all of the 25s to what?
30.
To 35, right? Because we went up 10 more years.
I just got mind blown.
I love this.
So we just changed them all to 35.
So then it should be 40.
Hit enter.
7.8.
787.8. And then we go back through and we do second enter again, and we put in what? And we put in 40.
Oh, okay. Like you were yesterday, so. I'm feeling every day. Oh, yeah, I got the first one. 1,000. Got it. Oh, I said it first.
Closer to all right. 1,072.1. Those are all in millions. Okay, good. Okay, you're all on your own. Okay, this problem over here says that you're starting at 1970. It's the life expectancy of females based on their year of birth. And so you're going to do the same thing. Stat edit, you guys can start typing stuff and you don't have to wait for me. You know you're going to start with 0 though, right? 0, 10, 20, and 30. Okay, we get it all typed in. We have 4 points, so we know it's going to be what kind of regression? Cubic. Okay, now, this is real important. You're going to have to really make sure you're paying attention to this. Do you see you see A here?
Yeah.
Do not put down 1.33 because you got to look and see that e to the negative fourth, right? And so we have to move this decimal place right here. See if I look it out of the calculator. It won't. We have to move that decimal place 4 to the left, right? So it's going to have, what, 3 zeros in front of the 1? So it's going to be, .00013 repeating x cubed. Okay, minus 0.0105 x squared plus 0.3. I knew it was going to turn off on me.
How do you look at your calculator? How do you do repeating? Yeah.
You don't.
Great.
0.3616 repeating x and plus 74.7. All right, here you go. If you're going to estimate this stuff, I'm just going to do 1986. You guys get the gist of it. You can do the rest of it. So 1986 is going to be what, 16?
77.1.
16 is what we have to plug in for x.
Yep.
So did you already do it?
Yep.
All right, so you've already typed in what'd you get?
77.8184. See, I got 78.3. I got 83. What are you supposed to
Okay, tell me what you got. 77 what?
0.8184. How do you do repeating? I got 83.
Okay,
Because I rounded.
here's the deal. The more decimal places you put out there, the closer your answer is going to get. But for us, we know that 1986 is between 1980 and 1990. So we know that our answer's got to be someplace between 77.4 and 78.8, right? So it's a pretty good guesstimation that 77.8184 is close. You might have to round a little bit. You probably want to go further out in decimal places if you want a more exact answer. All right. This says find a cubic and a quartic model for each set of values. So now they're telling you to do both. And then you have to determine which model best represents the values. So we're going to hit the stat button. We're going to edit. We're going to type in all these values here. So we've got -2, -1, 0, 1, and 2. And then we're going to go over here, and we're going to have -7, -3, 3, 5, and -3. Okay, those are y values. We type them all in. We have to do the cubic and the quartic model. So we'll hit the stat button. We'll go over to calculate. We'll do the cubic first.
R2 equals.
Those are not
Oh,
the
wait.
numbers that I got.
What did I get?
I think
That's not. No, that's your numbers are wrong.
Did I type something wrong?
What I
you
got.
had 7 in there twice. It's supposed to be -7, -3.
Oh, right here?
5.
What happened here?
You typed them in wrong.
Okay.
It is wrong.
So it's -7, -3, 3, 5, and 3. So that's right?
Yeah, that's right.
Okay.
And then I listened to myself and it sounds good.
There you go.
That's what I got.
Okay.
Still not what I got.
That's what I got.
I got you.
Okay. So, next, less talking. Pay attention. Hit stat. Go to quartic regression, because that's what they told us to do. And now look what happens.
Why does it do that?
You see how it's got a 0?
Why does it have a down E?
Okay, don't worry about that right now, because there's more down there. You have to hit the down arrow, and it'll show you what F is, maybe. But look.
No, it's just the R2 thing.
See how it says A is 0, B is -1, -2, 5, and 3. So the quartic model is 0x to the 4th minus x cubed minus 2x squared plus 5x plus 3, right? Which, if you look at it, it's the same thing as the cubic, right? So then, which model best represents the values? The cubic does. Okay, you don't need to write down the r squared value. Now, if we go over to this other one, well,
Wait, why again is it?
because the quartic one, what happens? What's 0 times anything?
0.
0, it's gone, so it's not even quartic anymore. There's no 4th power x. So it just ended up being cubic even when we tried the quartic model. Okay? If you go over to the other one here, and you type in everything, so stat, edit. This is -2, -1, 0, 1, 2 again. So then over here we've got 2, -6, 2, 8, and 42. That's not 42. 42. Okay. Stat, calculate the cubic model, regression first.
It's weird because it's got R2 is 0.97.
Okay, that's fine. That just means that not all the points purposely fit on there. So you get, for cubic, you get x cubed plus 5.857x squared plus 6x minus 2.114. All right, and our r squared value is 0.9767. Okay? Then quartic, when we type that one in, second
Yeah, I got
stat,
numbers too.
oh, I didn't mean stat. And you go to quartic and you hit enter, you get 2x to the 4th plus x cubed minus 3x squared plus 6x plus 2, right? And then when you scroll down and you look at the r squared value, you get an r squared value of 1.
Quartic is better.
And so, this is your answer.
Put myself in time.
And here is your homework.